Hi guys. Today we are going to continue with the imaginary components in math. Okay. In order to understand the mathematical concept of this term, is basically related to what our signal definition. Okay. And so this is our title. It's given in here. And now the section 1 can be defined with the imaginary component in math. Okay. So what's the imaginary? Imaginary means that dreamable object which is non-exist in the universe, okay, but we feel it. We don't have any 3D dimension formula for these things, but we can visualize the whole results by using the axis, because just remember that we can collect the whole forms as a real or imaginary part of these terms, okay. And so if we have a right angle in here, or the 90 degrees between the two axes, and then we can define any other axis, okay. And so Hilbert proves that, okay. This is the Hilbert space, and so it has also roots and obeys the Pythagorean theorem, since it has own axis and interact with the reality, okay. But we cannot see this term, okay. Just remember that. In order to understand the imaginary, we need to comprehend the two mathematical notions to prove that. First of all, we need to utilize the Pythagorean theorem, okay, and also derivative notion, which is derived in the calculus, right? And so Newton found it, okay. So we can create the real axis in here, and so it has the 3D dimension, but we have also an imaginary axis in here, okay. And then we can interact these two things because we have the right angle in here, okay. And also, as we know, we have talked about these things in the previous lesson, okay. And so Democritus state the universe has a base with the what? With the atom, right? It's compounded with the basic units, which we call it the atom. And so in math, this idea converting into the geometry plus algebra, okay. And so we can add another dimension or the axis in order to what? In order to represent anything in the algebraic form, okay. And so we may not see this imaginary axis, but if we want to use the geometry and algebra, we can see the results of these terms, okay. And so we don't have any imaginary geometrical representation in real life, physical life, but we can model it by using the math in here, and also we can measure the algebraic results of these terms, okay. So what's the relationship between the atom and the Pythagorean in here? We can say that just like the universe, the Pythagorean theorem is the basis of the math, okay, just like this one. And so this is represented with the energy of the math, right? Just like this one, or in philosophical thinking we call it the essence, okay. And so this Pythagorean theorem interact both the real dimension and the imaginary dimension. Okay, this is the basic idea coming from the creating the imaginary component in the math. Okay, and so according to Pythagorean theorem, every distinct feature is interacted with each other, and even if they are different, which means that we can connect energy into another form, just like the kinetical energy or the potential energy. And so based on this information, we can derive the another form of this term, just like this one. As you know, we can use at every time the derivative operation, right? And so we have always a t, time, and x is any variable in here, just like this one. And so we can build the right angle in here, and then we can derive any signal like this one. Okay. And so how about this signal? First of all, we can write that the x is always triangle or right angle with a t, and so some rules obeyed by the signal, and we can form the t and x, or we can create the x t. X is a function of time. Okay, because if we know these things, and then if we have the right angle, and so these are two things are the different features. Okay, and so we can write this xt signal variable. But how can we link these two things? Just see that if we have this nomination, and then we can build the one Pythagorean triangle in here, and we can drive the delta t and delta x and delta s in that case. Okay, these are the generic feature of the building the Pythagorean theorem. And so this Pythagorean theorem builds or creating this signal, because it's the basis of this signal. Okay, and so the every xt or another signal is the compounded of the Pythagorean rules. Okay, and so I, j, k can be built with the summation of these terms. Okay, because we have the t value in here, time, and so we have the deflection rate in here, just like this one, and so we can build the delta s in here. Okay, and so we can link any distinct feature, position and time to each other using the Pythagorean theorem. But we can also write this term, just like this one. This is a right angle rule in here, t1 or y or z or a or b, blah blah blah. We can also build these nominations in here. Okay, and so the signal can be transformed or defined with the new definition. The signal can be considered as the collection of Pythagorean triangle, and this triangle preserves it to continuity. Okay, and so this Pythagorean triangle proves that this continuous signal, we don't have any discrete feature in here or discrete time feature. Everything is just linked with with the previous term or the forward term. Okay, and so the signal can be defined by using this nomination, and after that we can conclude that we can split or collect the signal with the another axis, features or functions or signal because at each case this Pythagorean triangle just react or interact with this signal or function or feature or axis. Okay. And so the Newton uses that idea in here. Okay. And so section 2 is related with what? The derivative notion in calculus. Okay. How can we prove the derivative operator in calculus? Upon the previous example, we can conclude that the ratio between the delta x and delta t. I can just write this term in here, just like this one. Okay. And so delta t and delta x and delta s can be written in here just like this one, and so the ratio between the delta x and delta t always is preserved, okay, by an area equality in here, even if this delta t goes to 0, because if we don't have any relation in here, and so we cannot build the signal in real life or physical dimension or in math, because their discrete part of this signal cannot be built to what? To continuous signal. Okay, this is the basic term for the what? For the physical representation of the math in here. Okay, and so continuity happens in any signal, otherwise everything is discrete. We can conclude these terms. Okay, continuity happens in any signal or any dimension, otherwise everything is discrete, and this is not useful in real life application, because we have the continuous signal, we have everything in physical world, we have continuous. Okay, but just remember that if we are using the computer or the microcontroller, we should discretize whole the system, because we cannot reach the higher sampling ratio for the what? For this operation, because our microcontroller is based on or is built with the what? The transistor 1 or 0 signal, and so this signal is running with the continuous time, but the process or the evaluation of the signal must be always discrete. Okay, and so but in physical world we don't have any discrete object, otherwise we collapsed or the universe collapsed. Okay, and so using this information we may have the behavior or the tendency of the any signal x with respect to the distinct features. So in summary, we can define tendency between two signals, because we can link these two signals even if we have the right angle in here. Okay, and so this can be x, or this can be t, or this can be y, and so we can write what the t with respect to the x, or y with respect to the x or t in here. Okay, and so in math or physics we have draw the new dimension in here, or the signal, just like this one, xt t. Okay, and so we can build these terms in here, and after that we can put the one Pythagorean in here, delta t and delta x and delta s. Okay. And so what's our conclusion? If there's a relation between the position and time, so we can write the what? Delta x and delta t and x dot. And so this is rational or logical in here. And so if we have this information, delta x and delta t, and so we can trust the x dot value. It's the derivative or the notion of these terms, because the Pythagorean theorem proves that the area must always happen in order to prove the what, the continuity, right, or continuous signal, and it closes to zero, and as well as we have used this notion. Okay, and so Newton used this idea. But how can we define the delta t value to represent a physical identity? And so Newton just used this notion. If we use the limit operation in here, delta t goes to zero. And so this is the smallest part of the math of the universe, of the basis of the math in here. And then he assigned what, the delta x and delta t value, right? And so if we have this information, and so t plus delta t minus x t, this is the present value, this is the forward value, and also delta t gives us the differential form. Because at every case Pythagorean triangle must happen. This preserves the every energy which is given in the math, in the signal, in the dimensions. Okay, otherwise we cannot write any dimension in physical world or the mathematical world. Okay, and so Newton used this notion to what, to create the tendency between two signals. One of them is the time, one of them is the what, the xt. Okay. And so if it is related to the time, then Newton conclude the three statements in here. Okay, first of all, it's based on the time, and so which we call it dynamic, right? Dynamic, coming from this term. And if it's any signal is related to time, we always say that it's dynamic, right? And so it's the derivative, but also it's a dynamic. And so Newton used the idea to create the mass concept in here to what, in the 3D, two Pythagorean triangle. Okay, and so this identity is found by the Descartes, but Newton put to what, the name of this Pythagorean unit, which we call it the mass. Okay, and so according to the Newton's idea, Newton say that if the two Pythagorean used is the 3D, and so the energy form or the mass of this term is directly related to what, with the mass. Okay, and so Newton defined that the mass is actually is a creation of the what, the two Pythagorean theorem triangle. Okay, this is the definition of the Newton for the mass. Okay, and so it's the base energy, because the Pythagorean is a mathematical based energy. And then he found out that this mass is directly derived from the Pythagorean triangle. And also this triangle enable us to what, to condition the mass under the what, some dynamics. And so we can also relate this to this mass with what, with the dynamic, because we can use the calculus derivations or the rules in that case. And so mass is related to the what, is linked with the what, Pythagorean triangle. Okay, and so how can we utilize the time and differential to build the J? As you know, everyone can say about the J. But what is it? Firstly, section 3 can be given in here. Section 3, imaginary concept. So now we have the time which goes always forward, not backward. It's called the dynamicity. It's the joke of the universe. Time always goes to forward, not the back. Okay? And is always linked all the time with the dynamic, right? And so if we're calling the dynamicity or dynamic relation, and then we can call it what? The time, not any other else. Okay? And so what about the signal and its conditions? Turning to the signals in time, just like this notion. And so are time or signal growing or smalling or steady, right? And so if we have a signal, this signal can be growth or the small, or it preserves its energy or the values of this thing at a steady state conditions, right? And so how can we this always happen? Nothing more. There could be one of them for the condition of the signal. Okay? And so how can we relate these notions in here? For example, the A graph can be given in here just like this one. Okay? And T and X. Okay? And so if we have any signal in here and then we can evaluate the Pythagorean theorem. First of all, delta t and delta x can be given in here, and so delta t, delta x, and so delta t and delta x. At each case, delta t is smalling, but delta x is growing. This is the first case, okay? And so if we have any other condition, just like the B in here, like this one, the T and X, and so we may have this signal, just like this one, right? And so we have this nomination in here, delta T, delta X, and delta T and delta X, and the ratio of this term at each case, delta T goes to infinity, delta X goes to 0, because we don't have any dynamics at this case, right? Because at each time this value is closing to some points and smalling, okay? And so this is always growing. Or one of the case is the what? T X, maybe this one, okay? And so at each case delta t may grow or not, but the delta x is always 0. We don't have no dynamic in here. This three case can be happened, but we have a special case just like this one. T x t. If we have the notion of this term, and so some signal can behave like this one. Okay, we must consider this signal, because if we analyze this signal, and then we have the what? Delta t and delta x. Okay, we have the delta t and delta x. Delta t, delta x. Delta t, delta x, right? And it goes on, just like this one. Always have the deviation, and it calls the dynamic. But it returns returning to the same point at each case. So if we have this signal, and so we should analyze, because we cannot see the effect of this signal, which force or which effect returns this signal to the same point at each time, at each period. The time goes to the what infinity value. What is this effect? And so if we have this information, and then we can supreme or remove the bias term. Bias term is given in here just like this one, and so the zero values is coming in here. Okay, and so at each case we have the negative part or the positive part for the Pythagorean theorem. Okay, and so this is the positive and this is the negative, right? And so how can we analyze this signal to extract the effect which we don't know right now? And so we can use the Pythagorean theorem. Just remember that we have the at each case, delta t and delta x value, right? And so we have also delta s, and so we can write delta t square, delta x square, and delta s square, right? And so if we can derive the notion of these terms, and so dt square, dx square, and ds square is coming in here, right? This is the term of the delta goes to 0. We can write it just like this one, and so the delta s can be written just like this one, right? This is the rule of the delta s in here. And so how can we define this term in here at each case? We can see that if the signal returning to the same point and signal must be also returned. And so how can we define this notion in math rule? This is simply say that ds must always be 0, because it cannot change. In that case, to what if we take the integral of this term, dt square, dx square, x can be changed, dt can be changed, and so this must be equal to what? ds. And also this results must be provided with this notion, because at each case this ds cannot be changed, because if the ds change and the area change and the energy change, and so if we don't have or if we return to the same point at each case, and so this ds must be equal to 0. Okay. And so we have the t value in here just like this one, and so this is 0, and so in the integral form we can collect this form in here, 1 dx square dt square, right? If we collect this term in here just like this one, dt dx must equal I'm sorry integral dt must be equal to the 0 in that case, right? Because we don't have any real object or real representation in the real life. We don't have any change, but the effector coming from another place, another imaginable place. And so if we take an integral of these values, which is the ds must be equal to 0, and then we can say that this integral must be equal to 0. Okay, and so dt is not 0, and then we can remove this integral term in here, and then this term is the equals to the dx dt square is 0, And after that, we can write that the dx square dt must be equal to 0. And so what about that? This dx dt is equal to the what? Square root of minus 1. Just see that if the hypotenuse is constant or integral values of the constant, and so this dynamics, the x can be anything, but this dynamics must be equal to the what? The square root minus 1, which we call it the j. Okay? This is the proof of the what? The j. This is the notion of the j. And so j creates the invisible dynamicity of our real life or reality. And if it happens, we have some other feature which we call it the frequency. Then the infinite rules at whole time can be defined in here, because at each case we have one root, second, third, fourth, fifth, and goes on this time. But just use the ds must be equal to 0 notion in the integral form, because the t always goes to what? Infinity values. And so this equality can be defined or can be supplied with the what? With this mathematical notion, which we call it to the what? The j value. Okay? And so, any question? This is the proof of the j. Do you understand what I'm saying? Or what I teach in this lesson?
Hocam bir şey sorabilir miyim?
Please use the meeting chat, right? That's the my voice header is the broken. ds is equal to what? The hypotenuse values. I can see, can write this term just like this one. You must see that if the ds change in here, and so the dt and dx can also be changed in here. But we can see that we have at each time return to the same point. For example, x goes to 0 and x goes to 0. T 0, T 2. Okay? And so, as we know that if this is the case, and then this delta t, delta x can be changed. But if we are returning to the same position, we cannot lengthening or narrowing this ds value. Because if this is the case, we cannot return this point at this time. Do you understand this thing, Fatih? If the ds is changed just like this one, and so ds is always equals to the what? The delta t or delta x. You can see that. In this case, the ds is equal to the dx, right? In that case. In this case, ds is equal to the dt. At the what? At the time goes to infinity value. But in our case, at each time is neither equals to dx or the dt. Which means that this term suppresses or removes to each other. dt removes to dx, dx removes to dt. Which means that ds at integral form must be equal to 0. Do you understand that notion, Fatih? Just see that in the growing signal, we have the dx must be equal to ds, because the dt is always smaller, but dx, yes, ds is always same length, and then we can convert or define to what? The roots, and we can convert in the next lesson frequency to the time, and each prefers the hypotenuse always prefers to what, or keep the what? The energy is constant. Just see that. Have you heard about the Euler identity formulation? For this form, we have always constant R, just like this one, right? You can see that this is the real and im, right? And so this R is always kept constant, which means that the energy of dx dt or real im are constant. We can take energy from the real part or the imaginary part, but in always we should define to what we take the dt energy into the what, into transferred to the x, or x transferred into the what, the t, right? In that case, otherwise we cannot return to the same position, which means that we have the 0. And so at each case we have the 0 0 0 0 0 0 0. This is called the what, the dynamicity, and this is called the what, the infinite root. And so this case creates the what, the infinite roots at whole time. And so we can model everything by using these terms, which will call it as a frequency. Okay, Fatih, do you understand what I have talked about? Mass is the basic definition in here, just like this one. Just see that this is the Pythagorean, and so every object or thing is contained with this 3 dimension, right? X, Y, and Z. And we don't know anything about the objects. We know that it is filled with the essence, thing that we know, or the energy. You can use the definition of the energy, but you cannot understand the energy. We can transfer the energy one form to the another one, but we don't know the meaning of the energy in here. We cannot define it with basic constant or the definitions. We just assume to what this is the energy, just like this Pythagorean. In the Pythagorean theorem, we built the what, two Pythagorean triangle to create 3D or 3 dimension, x, y, z. And so we have the volume, and the Newton defines that this is not just a volume, this is something else, this is mass. Okay, and so we can define the mass in the 3D just like this one. Because it contained with the what, 3D dimension. And so this dimension, one Pythagorean, triangle, this is the second. And so this 2 creates the volume, and this volume is utilized by the Newton as a mass. Just see that we have the volume values of these terms, but in order to comprehend the mass, we define the rho, density value of this term. And so this density is the ratio of the what, this volume can interact with the universe at this case. And after that, by using the calculus, x dot can be definable, or the derivative notion. And so this x dot can be linked with the mass value, because it is they are sourced with the same base. Okay, and so we can interact the mass with the time, and also we can build the physical law, just like the Newton's law or any other physical laws, which is given in the electricity or the what, the physics or the chemistry. Okay. Any question? Okay. And so, if this is the case, we have an academic ceremony in the Davutpaşa campus. And so, in this week, this is the end of the lesson. I hope you understand what's the condition of these things. But in the next week, we will complete, or we will continue with the Taylor series and its proof of the what, the E, Euler number. Okay?